If I come to the two terms, I think few students at least can recognize what are the two terms, okay, which are very much required in our physics in almost all the chapters, not only in one single chapter. Okay, their names are, one is the differentiation, and the other one is the quite inverse process to differentiation, which is called as integration. Simple from English, you can understand, you are differentiating the things and you are trying to integrating the things. I think these two English words, you know, differentiating the things, okay, and integrating the things. Those two, how we use in mathematics. This one you have to take care. Okay, here you have to listen very carefully, otherwise you can't understand. So take care here in this concept, and later don't blame me. Right? Yeah, these two. Yes, Laliti, you're right. Coming to here. First, if I go with differentiation, when we use this differentiation and integration, both if you ask, I say, if something is changing with respect to the other. Sir, we did not follow what you said, sir. What, Rana? You said something is changing with respect to the other. What is changing with respect to whom? We did not follow, sir. Okay, very good. Now observe one example here. Say the displacement or distance. Are simple to understand. This one you can easily understand. The velocity of a body changes with the time. Okay. Here, this is what I said. If something is changing with respect to the other, with respect to the other means other is time, something is changing means velocity is changing. Okay. Then here immediately what I am going to say, I think already few students thought. Okay. Immediately we try to calculate its acceleration. Why? Because rate of change of velocity is defined as acceleration. So here to find out the acceleration, immediately we try to write. Say the velocity changes with the time. The acceleration of the body can be written as A is equals to, I write here, your known formula in your 10th class or 9th class, change in velocity divided by time. Okay, you can use this formula. From this, I think you came to know in your 9th class that change in velocity, we write it as final velocity minus initial velocity divided by time. And from this, I think your ma'am has taught one equation, means AT is equals to V minus U. So that I think now you can recollect one formula what you learned in your lower standards, V equals to U plus AT. I think it is a famous formula. All of you remember. Is it not? All of you know this. Yes, yes, yes. V equals to U plus AP. Yes, all of you remember. Yes, I believe. Okay. So this formula we already came to know, sir, and we found the acceleration here by taking change in velocity divided by time, sir. Then here, where I get this differentiation, here I'm not finding any complexity, any hiccups, or any thing unknown here, sir. This is very easy to digest, very easy to understand. Okay, here, this one, they won't, whether that your ma'am taught or not, I don't know, in your schooling. There, actually, this is a conditions applied formula. Okay, few conditions are there. Like here, while purchasing the products, they put some star marks. Okay, so in the same way, conditions applied while using this formula. What are the conditions, sir? First you say, later we decide our ma'am or sir taught it or not. Okay, first I am going to say here, the above formula is applicable while solving the problems. Okay, only this is condition what I'm saying, the star mark. Only when the acceleration is uniform. Now you decide your ma'am or sir taught this point or not. Okay, now this is the time that you have to decide. The acceleration is uniform. Yes, okay, that's fine. So when the acceleration is uniform, yes, yes. When a body is moving with uniform acceleration, then only the above formula is used. Means A is equals to V minus U by T is applicable. Okay. Uniform acceleration means the velocity should be changed uniformly like this. How, sir? Suppose like you are driving a bike or car and the speed is changing like a 0 to 10, 10 to 20, 20 to 30, 30 to 40, like in every 1 second. Duration here to increase from 0 to 10 is 1 second. Here also 1 second. There also 1 second. And finally here also 1 second. If the velocity changes, this is velocity and it is time. Changes uniformly at regular intervals of time, equal intervals of time, regular intervals of time, then the body is said to be moving with uniform acceleration. Acceleration is uniform. Okay, this is the condition what we took. That's why the T is here. For explanation, I give one example. Okay, but who knows all the times the velocity changes from 0 to 10 to 20 like? Okay, depending upon the requirement in the traffic, sometimes we slowly move, some other times to jump the signal after seeing the yellow light there, okay, before turning into red, immediately we try to raise the throttle of bike and we try to cross the signal. It is our daily life. Okay, being an Hyderabadi, we do like that. Okay, so here this is the problem. Means the velocity is changing irregularly. Okay, if the velocity changes irregularly, like velocity changes 0 to 10, 10 to 40, 40 to 100, again 100 to like 160, okay, or 150, like here changes. Irregular changes. Here changes 10 just in a time of suppose 1 second, 10 to 40, Suppose it happens in 2 seconds. At 40 to 100, this happens in 1 second. 100 to 150, this happens suppose in 3 seconds. So see here, the time intervals are irregular and the velocity changes are also irregular. Okay, that is, here I write in the above example, that is, the body is moving with non-uniform acceleration. Okay, this is the dangerous case. Here we require the help of again mathematics. If there are non-uniform changes, not regularly, irregularly the things are changing. The physical quantity is changing with respect to the other. Irregular changes I'm finding out here. In that case, to find out the physical quantity, what you require here, okay, we should not use this formula to find out. Okay, for that, they give one method to find out. That method, we are calling it as differentiation. This is the method we are going to use in case of non-uniform. Okay, so the differentiation method here, differentiation or its inverse process, integration, is helpful to find out the non-uniform changes. Okay, sir, why you left the gap here, sir? Just casually the marker moved to there? No, wantedly moved to there. It is not an accident, it is an incident. Okay, so to find out the non-uniform here, the differentiation method, few students may go into a wrong perception. What? Arey Baba, here the sir told Ray differentiation or integration used only when there are non-uniform changes. Who said only there are non-uniform changes? This is the way what we are understanding the English. I said here the body is moving only with non-uniform acceleration. No, moving with non-uniform acceleration, you are just helpless here to use this formula to find out the acceleration. To help you, we provided a method. Means that method is useful not only in case of non-uniform, even in case of uniform. Non-uniform or uniform changes. Whether there are uniform changes or non-uniform changes, in for both you can use happily the differentiation or integration. Okay, so don't go into misconcept. That's why here that what I'm saying, the differentiation method, how you write the differentiation and in what way you use it in your physics. Okay, if you see it there, here I say, Arenana, here differentiation, first you have to understand how to represent it. That is very important, Ranana. Okay, sir, first you tell how to represent. Look at your definition there. Say again, A is equals to what you wrote there, change in time, sorry, change in velocity divided by time. Okay, then A can be written as, usually change means, I think you know in your lower standards, change represented, change will be represented with the letter some delta. Delta into V divided by This time, suppose small intervals, we write it as delta t. I think you know this representation, am I right? You know this representation on a delta representation? Do you know it? Yes, yes. If there are changes, we represent with the delta. Okay, good, good. Here, those changes are whether uniform or non-uniform, same thing in mathematics, we write that delta changed with the letter d by delta t by dt, okay, into v, okay. Then immediately student will again go into a misconception. Array, this is very simple, Ray. Here, like above equation, delta v by delta t means delta delta cancel, and we write it as v by t, Ray. Is it correct? Delta delta cancel at the numerator and denominator. Will we cancel like this? Array, delta cancel. Ah, right. What you are saying, like sine 30 by sine 60 means, Array Baba, here sine cancel, Ray. This is 30 by 60, Ray. 30 by 60 is 3, 0, 0 cancel, 3 by 6, Ray. That is 3 ones are 3 twos are. This is 1 by 2. Is it correct? Yes, Lalit. Okay. Yeah, we may go into some misconceptions sometimes. So here, in what way you are laughing there now? Here, Ray, what the sir is saying there, Ray, sine cancel at Ray. You are laughing there now. Say in the same way here, you are agreeing that this is wrong, and you are agreeing that this is wrong, cancelling. In the same way, if you ask me on a fine day, sir, here shall I cancel D and D? I also laugh. Okay. If there it is not possible to cancel, then here how you cancel? Okay. So here delta v by delta t, here also don't cancel d and d. They represent the changes. Okay. But represented instead of delta in a different way, d by dt, and giving its for it a name called as differentiation. Here d by dt, this is called as differentiation. Okay, slowly we are able to understand, sir, what is meant by differentiation. In differentiation, we have to write who is changing there at the numerator, and we have to write with respect to whom it is changing, we have to write it at the denominator. We understood, sir. Okay, cross-checking. Okay, here whether to what extent you understood or not. To what extent you understood this concept, take a little litmus test. Okay, suppose here I say y is a physical quantity is changing uniformly or non-uniformly with respect to x. Okay, then how to write this one with respect to x in differential form? In differential form, it can be represented as shall I write like this? First d by d with respect to x. It is changing with respect to x. So d by dx of who is changing? Yes, y. Y is changing dy by dx. This is the way of representing the one. So first of all, the basic way of representing the differentiation, I don't know whether all of you followed or not. Okay, all of you followed it, Nana? The way of differentiation? Okay, thank God. So first of all, Yeah. The introductory part for differentiation, I think you felt a bit easy, okay, to understand. In this differentiation, problem is in mathematics, they provided many formulae for application. Okay, what are these? Are simple, like a sine square theta plus cos square theta equals to how much in some problem. Then mathematics provided that equals to 1. Okay, no problem. Who is this Rohit? Okay, right? In the same way, like sine 2 theta, somewhere in our physics, if you get one formula, immediately mathematics masters, professors, they provided one formula for us to sine theta and cos into cos theta. Okay, these are all the trigonometric formulae which are helpful for us in our physics. Okay, in the same way, they gave few formulae in the differentiation. Okay, those formulae I am not discussing all, just I am providing few which are useful for our physics. Means again started filtering all the formulae. Filter the formulae and which are required, okay, take out from the here pile of formulae, bunch of formulae, okay, stack of formulae. From them, we are trying to take out wisely what are required for our physics. Okay, those formulae here I am going to write, right? Try to understand those formulae. Here I am providing the formulae only. They are suppose d by here dx, okay, of y, where y is given as y equals to first y equals to I am writing x power n, first formula. Then here what is the value of d by dx of x power n? This is the first formula, very frequently we use. I think Nishal Balaji not one, Nana. Okay, d by dx of x power n. This one try to remember, Nana. I am slowly writing here. X power how much is there? N. So first you write n into x power, reduce its value by 1. Reduce means minus 1. Now you understood how I wrote this one? D by dx of x power n equals to, I write here, this n first, n x power n minus 1. Okay. So here look at wisely, sir, where I use this mathematics formula, this is actually mathematics formula, where I use in my physics, sir. Suppose somewhere you got like d by dx of, in solving a numerical, x square, same. Now I think here, who is this Omaricha? You can understand from this example. That's what I say. Okay, d by dx of x square. Then here we have to continue to solve it now. To solve this, we require a formula. What the formula is saying, if you get a power, some n like n, then the value will be, after differentiating, you will get a value n into x power n minus 1. Okay, now look back here, x square, x power how much I took here? 2. So in place of n, how much I took here? Once you check, this is 2. So I am going to apply this formula, like n is how much here I took? This is 2 into, yes, Lalit, 2 x power n minus 1. N is how much here? 2. 2 minus 1. Okay. Yes. So I'm getting d by dx of x square is equals to 2 into x power 2 minus 1. That is x. Okay. Wisely catch the point here. While differentiating, you are trying to reduce the value. Differentiating, separating. Here look at x power n became x power n minus 1. X square became x. Value is reduced or not? Okay. Then here, how to write every time to remember this one, sir? Instead of remembering this formula, sir, here, is there any logic to apply this formula? Oh, you want the logic? Okay, then look at here. Whatever the power coming there, that first you write here, followed by x, reduce this value by 1. Okay. Now, sir, will you give one more example, sir? Sure. Look at here. D by dx of this time x power 5. Okay. Quickly you observe, I am writing what I am writing. Quickly I am writing, oh, x power 5 or 5x power 4. Now you understood how I wrote? Able to follow? Yes, very good, very good. Okay, here just I'm not solving, just I'm asking you all. X power 7, how much you say? Seven x power 6. Wow, nice, Shiva. Very good, very good. Yeah, even here also I got the answer. Now here, I think you understood what I'm saying. Is your doubt clarified? Yeah. Yes. Yeah. So here 7x power 6. Simple. The same number reduced by 1. That's it. X power 12. This time very quickly we say 12 x power 11. That's it. X power 21. Very simple, sir. 21 x power 20. Now I think you understood how to apply this formula. Okay, yes. But problem is here, if it is x power, suppose exactly I take 1, that time you have to say how much is the answer. X power 1 I am asking, just x. I think you can say the answer for it. X, Tejashwi wants to think wisely. D by dx of I am asking x. Yeah, exactly. X power 1 here. So I have to write 1 x power 0. Am I right? Okay, 1 into x power 0. Exactly. So x power 0 is how much? Any power 0 is 1. Yes, not only x power. Yes. Any power, y power 0, z power 0, p power 0, t power 0, anything power 0 is 1. Okay, so here you can say this is x power 0, 1. 1 into 1, you can say d by dx of x is equals to 1. Okay, very good. Oh, d by dx of x is equals to 1. Shall we remember like a formula, sir? Happy, you can remember it like a formula. Like how you remember this one. Just I am going to highlight. This is the original formula. From this one only we are extracting the things. In that one more we have to remember d by dx of x equals to 1. Sir, I got one idea, sir, here, and I got one doubt. Actually, it's my doubt, sir. You here try to reduce the power to 1, sir, like x square, x power 5. Now, suddenly you ask x power 1. I got one doubt, sir. Suppose if I get d by dx of x power 0, sir, reduce still more. Then, your answer. I think whatever you are thinking in your mind is correct. Yeah, Rakesh, exactly, you're right. Is it 1? No, I think previous postings, these are all. Rakesh, you are right. Very good. X power minus 1 regulation. First, you look at x power, how much is there? 0, na? You are forgetting that power first. 0 into what you are saying x power minus 1 is correct. 0 into x power minus 1 is how much? 0 into anything is how much? Yeah. Shanmugadatta, understand properly. Yeah. So 0 into x power minus 1, using the same method, above method only. 0 into anything equals to 0. Okay. This one we use like d by dx of this one, what we remember. Okay, x power 0, d by dx of x power 0. Shall I write it as d by dx of x power 0, 1. X power 0 is 1. So 1 means, shall I write it as a constant? 1 is just a number, Nana. Number is a constant. Na? So d by dx of constant, I write it as like x power 0 is always equals to 0. Means what you are saying, sir? Simple, Ramana. D by dx of, suppose I ask 4. How much you say here? 4 is a number, na? Number is a constant, na? Don't ask anyone. Are d by dx of 4 at I don't know, Ray. Their x term is not there, Ray. Don't ask. Directly you say the answer 0. Oh, we are slowly understanding, sir. Suppose if I get d by dx of minus 4, sir. Array, whether it is plus 4 or minus 4, that is a constant or not? Oh, it is a constant, sir. Constant means what is the differentiation? A simple, sir, that is 0, sir. So is it clear? Any doubt here in the differentiation of constant? Very good. So I'm going to highlight this one that you have to remember. Yeah, any constant is 0. That's what I said. Any constant, any constant. Right. Okay. So for today, you have to remember the basic formula d by dx of x power n equals to what? And here the x power 1 is how much? X power 0 is how much? These are the 3 formulae we learned in the new mathematics, that is differentiation. So shall I stop the class here? Yeah.